Hello, everyone, and welcome to this week's installment of ClueCon Weekly. This week we have with us Andreas Granig, founder and CEO at Sipfront, which provides SIPP testing, a platform. I think it's a CPaaS. Thank you for joining us, Andreas. Would you like to give us a quick introduction about yourself?
Sure. Yeah, I'm in the telecom, let's say, business for around 20 years already, doing close to 16 years of SIP development. And I've actually started back then in 2004 when I started working with SIP in particular, building soft switches for a small internet provider. And after that, like in 2007, I co-founded with a friend of mine Sipwise, where we basically built based on open source software, like a commercial soft switch for medium to large enterprises, mainly in the class 5 space. And yeah, out of that, particularly in the open source environment or open source ecosystem, people might be aware of RTP engine that came from Sipwise. Yeah, that was quite a challenging time in terms of, putting features into soft switches, creating more and more variants for particular customers. And what I always actually lacked there was a proper testing system, some framework that you could easily utilize in order to, with ease and with confidence, change things without the fear of breaking something, right? Because, we were doing a lot of Kamailio development, for instance, and our configuration in the end had like 20,000 lines, and touching something there was quite impossible without, breaking certain use cases. And, the test coverage has always been a bit of a problem because, as I said, there just was no real tool out there to properly test things. And Sipwise got acquired by Alcatel-Lucent in 2017, and when I left last year, I took this particular challenge with me and said, now I really want to tackle SIP testing once and for all, not only for me but for everybody else. And this is how Sipfront came to life, right? In the beginning, it was more like a proof of concept, taking SIPP, which is a really, really great tool, but it exists since 2003, I think, and it shows in terms of its concepts, right? Because it has like 150 command line switches, and you can do everything with it. But if you're not working with it like on a regular basis, then you just forget about all of the switches that you need to put in there. You have to do very low level scenario crafting, right? And what I wanted to do is just want to make it accessible in a way to say, just put a web interface around that as a first step, right? And be able to scale that, just have like a couple of SIPP instances running and report all of their metrics that SIPP provides into a backend and then show it to the user. And that actually worked quite well. And out of that, the Sipfront product, like a SIP test automation as a service, got created. And this is where I'm basically today, right? And it's helping customers like mobile operators, fixed line operators, and vendors alike to very easily, very quickly launch a couple of load tests, functional tests, security tests against their systems to help them, develop new features, and also to help them check like core qualities of SIP trunks and just overall improve the quality for end customers' experience. Right?
Cool.
And
so, sorry, go ahead.
Yeah, no, talking about end customer experience, one particular thing that needs testing is a new standard that actually comes up, particularly in the US, which is steer shaken to fight robocalls. Right? And I was participating in at the Open SIPP just in April, I think, where open source soft switch or proxy and application server vendors, PBX vendors like FreeSwitch, Asterisk, OpenShips, Kamailio, came together to do some interop testing. And I actually joined this session basically representing SIPP in order to provide something like a framework to do the testing automatically. Otherwise, if you do these kind of tests, it's really a pain to run through it manually again and again and again. And there are like a lot of tests. And we will later see, I will go for a quick presentation, what could actually go wrong with steer shaking and where some test automation might help in that regard.
So many people from the SignalWire team were OpenSIP too, and there's a lot going on in the steer shaking. So before we go back to that, and let's focus on SIP testing for a while. You're a testing expert, so what do you think people should be testing when they build a SIP-based infrastructure, and what are they not doing that's wrong? Like, why? What do you see that people are not doing right when they're testing?
Well, there's actually not a lot of testing going on at all, because usually, particularly with SIP, you need to kind of simulate end devices, right, in one way or the other. And it's pretty hard to automate these kind of things. In projects I've been working with, we had 10 people on a team doing day in, day out, picking up the phone and manually placing cores and finding regressions. And next day, vendor came in, updated the software, and you had to do that again and again and again. It's really tedious. It just doesn't scale, right? But on the other hand, the core flows sometimes get so complex that it's just not easy to automate things. Like imagine in the PBX space, for instance, you set up a core from A to B, B needs to transfer to C, and with all the re-invites going on, audio is being dropped, and then you end up with one-way audio, right? And you somehow need to, in one way or the other, properly be able to reproduce this and to test this. Right? And so there are a couple of challenges there, and there are companies out there providing you with big boxes, right? So you pay 100,000 euros upfront to get your test equipment there. But nowadays, it's 2021, right? And companies are moving their infrastructure to cloud services, AWS or Google Compute Platform, and they just don't have the infrastructure in-house anymore even to test this. So why would they run a big machine in their lab testing cloud services? So one of the main concepts really was that you as a user, as a producer, like a vendor of equipment or as an operator of equipment, you're not supposed to have these kind of machines sitting there, right, and having dedicated people trained on these kind of machines in order to operate them properly, to do your tests, right? So that was mainly the concept or the idea that you really don't have to be a telco expert to do or to create SIP tests. Right? Just you're supposed to either click on a button on a web interface, right, or run a curl command in order to launch your tests. And these tests come in different flavors anyways, right? So you have load tests, you have functional tests, you have even security tests. So there are a lot of things that you can do and should do and that are not always being done, right? And making that easier for people is basically one of my main goals with Sipfront.
Cool. So could you give us a few examples of what you can do with the platform, like some concrete scenarios?
Well, basically the easiest or one of the most obvious things is that, for instance, you as a vendor, you implement a new transcoding feature in your platform, and you want to figure out on a certain hardware how many concurrent transcoding sessions you can do, right? It's actually a load test where you actually want to configure, I have an Opus codec on one side, like for, WebRTC clients, and you have, PCMA, G711 on the other side in order to terminate it to the PSTN. And then you can or you're supposed to easily run a very quick test just to make sure, on a certain VM with certain specifications, how many of these cores your platform can handle. And one of the things here is really, as I said, the main goal is really to provide this as a service. And since it's running in the cloud, it has a limitation in a way that the system you want to test needs to be publicly exposed, right? Like in general. Otherwise, the tool wouldn't be able to, to originate traffic to the system. And this is one of the concepts that I was working on and tackled in a way to say, you can, in your premises, in your own network, just with a very small or very quick Docker command, launch test agents right next to your platform. These test agents, they connect to the Sipfront cloud, and then you can control them just via the cloud service, the Sipfront service, as the same way as a public agent. So you can run 10 different agents in your own infrastructure, and then via the same means, you go to the Sipfront web interface. You say, I want to do a load test against this particular machine, and I want to use this particular pool of test agents in my own network, right? So that I have a defined test environment. Right, so that, for instance, round trip times, jitter, packet loss of your internet connection are not basically limiting the test or changing the test result. So having this hybrid approach with, on one hand, software only, on the other hand, cloud, and on the third hand, still being able to run these tests and the traffic in your own network, I think this basically provides a very neat package that Sipfront provides.
That's very nice. So you also do media-based testing, right? Not just the signaling, which is usually what most people focus on.
Right. Yeah, I mean, for that, SIPP provides certain ways, to replay PCAP files. I did it a bit different. So I was modifying SIPP quite heavily. I think you were doing some work on media playing on SIPP as well, right, in the past, from what I've seen. I've looked at that. It's very neat. What I wanted to do, in contrary to that, was trying to scale that. So it's not, when I run tests, it's not just SIPP, rather than basically a full, a proxy and media engine infrastructure that you run in a Docker container. So you have SIPP. In front of SIPP, there's Kamailio. And Kamailio then sends the traffic to the system under test, and it can do manipulations and all kind of things that you as a user want to easily change or modify on the fly during a test. And it also runs RTP engine in order to measure call quality. Right? So when the traffic goes out, it traverses RTP engine, and RTP engine looks at the packages or at the RTP packets and is measuring the MOS quality. So you get, on one hand, the media bandwidth that you're utilizing. You get quality reports. You can even do RTCP. And you can, if you want, do transcoding as well. And this whole thing is being driven by a TCP replay, or a slightly modified version of that, where we provide PCAP files, for instance, 10 seconds long. And if you run a test for an hour, then it just replays this file again and again and again by modifying the RTP header in order, to have a incrementing sequence and have proper timestamps and so on. So there's a lot of things going on in such an agent, and and you actually want to keep the traffic per agents rather small, and then have a lot of these agents running in parallel, in order to drive 1,000 concurrent calls, because it's actually quite straining on a network interface. Of course, it's straining on its CPU. So you rather want to run a lot of these agents and not one big thing. So one of the main goals also here in the design was to really make this scalable. So if you want to really test your system and push it to its limits, a vendor sells you a soft switch and tells you that he can do 10,000 concurrent cores. It's actually quite challenging to test this, because generating 10,000 concurrent cores provides quite a lot of test resources. And this is what we can provide, like with the public cloud, to say, we just launch more and more and more instances, as much as you need, and then just run it against the system. And each of these containers then generates like 100 concurrent cores, for instance, and then it sums up. So that's the concept. Yeah, and I mean, load testing is one thing. Functional testing is the other thing. For that, I'm using a BSIP as a SIP client, for instance. You can very easily remote control a client via MQTT. You can, get the results back, and it doesn't provide you the big overhead of CP, where you have to define like the actual core flows down to the bytes that you actually want to send out, right? So you just focus more like on the functional side of things to check, does the test establish the core? Is the audio there? How's the audio quality? And then you can say, okay, and once the core is up, I want to do something with the core, like transfer it to another party, for instance, and check if you still have audio after that. Right? And the third thing, as I said, is security testing. I'm working with the guys from Enable Security there, like Sandro, and use their Sipwise Pro tool in order, for instance, to do offensive or a certain type of offensive security checks, right? Because from my experience, back at Sipwise, we had this, we had a huge focus on putting security measures in place to protect the customers. Right? So that was like DOS protection, DDoS protection, so that you make sure that, I don't know, if you are flooded from the outside, that these basically traffic sources are being shut down or being blocked, and if certain automated clients are trying to crack your password by sending too many password attempts, that they get blocked for a certain amount.
Oh, cool. So yeah, there's a lot to test, really. So I've done a lot of work with SIPP, including writing a Ruby library for handling some traffic around SIPP, and media was always the hardest part. Lost Andreas?
Hey.
Welcome back.
Thank you very much. My Mac just out of nothing completely crashed. So good that's not live.
No problem. So yeah, let's resume from there. As I was saying, I've done a lot of work with SIPP, and I even built a Ruby library to ease using SIPP a little. And the hardest part is always the media. Media has a lot of different problems. I don't even know if you can even do the TLS traffic over, so secure traffic over SIPP. Probably not. because you can't play that back really. There's there's a lot there.
Yeah, I've seen just yesterday when backporting my steer shaking patches to the latest version of SIPP that there is now a way to do secure RTP. I haven't tried it out yet, but actually it's there, right? It's very new, but I really need to look at that particular details. But this is one of the things where I love using RTP engine in front of SIPP. Because there I can drive dynamically the encryption and the decryption of the traffic. So I can actually choose when sending my call from SIPP via Kamailio to the other side, while the call is traversing Kamailio, I can control RTP engine and tell it from the flow from SIPP towards the system under test, change the media to DTLS, for instance, right? And the other way around, if the media comes in from the other side, change the media back to just plain RTP. And that's the beauty of using RTP engine and Kamailio as a tandem in front of any kind of SIP client, because in that case, the SIP client wouldn't need to, support all these features. And that's great.
Perfect. Yeah. So one question for you. You mentioned at the start of the conversation, we mentioned the store shaken and the fact that it's going to be important. First of all, what's the support that what's work and the support you do with Sipfront? And second, you probably have even more of a handle than I do on European countries. So is store shaking going to happen in Europe too, or is it something that we're not really caring about for now?
From what I've heard, the UK is actually looking into that.
Nice.
But other than that, I wouldn't even know that it's robocalling is a problem in Europe, right? I personally have very, very rarely experienced like a robocall or even spoofed numbers. From time to time, you see that. But typically, operators in Europe, they just they just don't let you choose any arbitrary number, right? If you are a customer of a telco and you have a SIP trunk there, you're actually bound to regulations and obligations to use the correct number. And if you're not, then what would happen, like in the best case, is that they are going to suppress your number, so you're coming in as an anonymous call. And in the worst case, they are just going to block you, right? And if you really want to use, like as a call center, for instance, if you want to do calls in behalf of, for instance, your customers with their numbers, then you need something that in Europe is called clip no screening, which is basically a feature that you get from your operator, allowing you to send arbitrary numbers. Right? So from that perspective, steer shaking as such is more, it's not really a practical thing that I personally need, but technically speaking, it's a very interesting challenge, right? Because it opens up a whole new set of issues. Actually, I mean, in the end, it looks rather simple, but if you're looking into the details from a technical side and also from a security side, it opens up a lot of new attack vectors that you really want to have tested properly. And back in our Open SIPP session, also with the Signal Wire guys, there were quite some surprises that we've seen, right? And for my steer shaken support in SIPP, I'm also using lib steer shaken from Signal Wire in order to validate identity headers. And if you're not careful there, you're up for quite some surprises. And I have a very quick presentation that I would like to share, which basically guides us through some of the concepts of steer shaking, because as we said, it's mostly for American operators and vendors. But in the end, there are a lot of soft switch vendors, like free switch developers that are, if they want to do business in the US, they are going to being confronted with that, and it's mandatory for us telco people to have at least a basic understanding how that actually works. So if you don't mind,
Sure. You go ahead and I'll set the layout up.
All right. So.
Or maybe there's no need. Yeah, perfect.
Yeah, let's go over that then. All right. So one of the things that I'm trying to do with Sipfront is to provide like readily available test packages. Right? So you're not only supposed to do like single load tests or functional tests, rather than going through a whole test suite, which you just run, and then it automatically launches like a couple of tests, in that case, even up to like 50 different tests in a row in order to the system. And talking about steer shaking, I would like to give a very quick intro what it is and why it exists, and certain challenges, technical and security challenges, and how you might be able to test this yourself, and also how you might be able to automate these tests. So steer shaking as such is actually a suite of protocols and procedures to fight call ID spoofing. It seems to be a very big and annoying thing in the US. And the US really wants to put a hold on that, and is requiring the use of steer shaking by June 30th. So actually end of this month. And
what I can tell you is that we ran some numbers a few days ago, and we saw that there were an average of over two robocalls per people a week in the US, and in some states they get almost one a day.
Yeah. Oh, that's ridiculous. Yeah. And I mean, the thing is that it usually is done with these spoofed call IDs. I mean, steer shaking as such is not going to be like the silver bullet to stop robocalls, but at least it's going to stop spoofing calling party numbers, so that the call doesn't appear to come from a trusted party, right? So with that, you can also flag them properly. So technically speaking, steer shaking is basically a procedure, a cryptographical procedure, where your call IDs, like calling party number, call party number, are being signed and are being packed into a SIP header. So when you as an end customer place a call to your operator, you yourself don't have to do anything, right? And your equipment doesn't have to do anything. But the operator is going to validate the calling party number, and is going to put the calling party number and the call party number into a certain format, is going to sign that cryptographically, is going to put a header, a SIP header, into the message, and then it's going to send it along to the next hop. Right? And the next hop then can take the information and can validate the information. And if it finds that the number is actually not legit, or I don't know, something has been spoofed on the way with this number, then the operator can block the calls, can reject it, or in the let's say in the standard case, can just flag it one way or the other, so that it can be traced back. That if you as an end customer get a robocall with a spoofed number and you are going to complain about that, it can be traced back to the operator who allowed this particular call in the first place. Right? And with this operator, you can most likely also go back to the end customer who placed this call. So the way it works is quite similar to the web world, where JWT tokens, Java Web Tokens, are being used for authentication. It's basically an information, a base64 URL encoded information with a header, a payload, and a signature. And all of that is put into an identity header. So what you can do is you can actually grab this header, and if you look closely, it's separated by dots, right? And I've marked it here like in colors. So the identity header consists of three different, the passport header. It's, if you take that and if you base64 or decode it, you will get a JSON document out of that. It's basically, it's not encrypted in a way, right? It's just encoded in base64. So you can take that and it just tells you, okay, this is a passport. which is defined in particular RFCs. It tells you the algorithms being used to sign this, and it tells you a URL with the certificate which was used to sign this particular information. More importantly, you get a passport payload, and in the payload you get origination and destination information, like the URI that has been used initially or has been validated initially by the operator, so that once you get a robocall, that you can actually look into this payload and check whether this information has been tinkered along the way, or whether the operator really took the correct numbers and put it in the payload. And all of this is being signed cryptographically in the JWT token, and it's being extended with directly in SIPP as a parameter with a link to the certificate. So what you would do if you receive as an operator a call with an identity header is you can actually fetch this particular certificate, and you can check if the certificate is valid, which is also quite important, right? Otherwise, somebody could just use a self-signed certificate and just sign whatever he wants to, and then double check that this information hasn't been tinkered with, and then take basically the payload, look at the origin and destination URIs or numbers, and validate that. Now, there are certain challenges with that, right? It looks rather simple. There are tools out there, there are libraries out there, like from SignalWire, for instance, lip steer shaking, that helps you a lot with this particular flows that you do. So getting it correct technically is one thing. This is something that with Sipfront and the test suite we try to address, right? That when you do this kind of course, that you are properly validating incoming requests, and you are properly raising flags, and you can properly react on these particular flags if the signature is not correct, for instance, or if information is not correct, like it's outdated in terms of the timestamp or whatever. There are security challenges in there, but that's also something that is rather technical, right? You can easily test this with the proper test tools. But then there is another challenge, like operational, let's put it that way, an operational challenge with the attestation that comes with steer shaking. And the attestation basically means that you as an end customer, you have a relation with your carrier, because your carrier is, doing the steer shaking signing, and you as an end customer, you send your numbers, right? So if you're a call center, for instance, and you have a contract with your operator, then you get assigned certain blocks of numbers that you can use, and there is no problem with that. What you get with that is full attestation from your carrier. So the carrier knows who you are, and the carrier knows that the numbers that you're sending are basically supposed to be assigned to you, so you can actually use them. Now, there are certain cost scenarios and business scenarios that are going to make this a little bit difficult on how you are going to manage this. Because if you think of like the scenario that I was mentioning before, you're a call center and you are placing calls, for instance, on behalf of your customers, and you are using their numbers, then you're sending to your carrier numbers that are not belonging to you, right? So is the operator supposed to allow these calls for you? Do you get full attestation, or do you only get partial attestation? Right? And the thing is, what happens if you're not getting full attestation? Is the call somewhere blocked along the way to the court party or not? Right? Or another scenario, for instance, you're using one carrier and you send all your numbers to this carrier, and then this carrier trunk goes down. Right? So what you as a customer, like a call center or an enterprise, are usually doing is you're going to reroute these calls to another trunk. Now, if you are using the same numbers that you ideally do, right? You are known under certain calling party numbers to your customers. So if you're rerouting that to another carrier, the other carrier knows you, right? But it doesn't know anything about the numbers that you're sending. So there are certain challenges apart from technical things that are going to be quite interesting, and I'm really curious how this is going to turn out, like how this is then solved in practice, and which consequences this is going to have. So in the best case, operators and customers are really going to need to talk to each other about these particular use cases. Like how is this going to be solved, right? Are you allowed as a call center operator to send like foreign numbers? Are you getting full attestation for that just to make sure that your calls are really going through, or are you only going to get partial attestation? What does that mean for you as a customer? Is there a risk that calls are being blocked along the way because of the the missing attestation? So every time you introduce this kind of new big things, there are going to be challenges. As I said, I'm really curious how this is going to be handled, and I'm going to have a very close look on the result and possible, and hopefully not the outfall of this. Right? The other aspect with steer shaking is security.
Yeah.
So with SIP, it's already kind of a complex protocol, right? It's free form, you can do all kind of nasty stuff with it. And now you're adding another aspect of that, like you're sending to another party a header with some encrypted kind of blob, right? Or signed blob. Actually, it's not encrypted, it's signed. And you send the other party a link to the certificate that is the other party is supposed to fetch from you in order to validate the signature. And this opens up a completely new protocol. You're suddenly supposed to not only support SIP and RTP and whatever comes with that, but also HTTP or ideally HTTPS in your soft switch, right?
Plus, you have to be able to trust that request.
And that's the other thing, because there is, as we're going to see here, is there are quite some things that you can run into if you're not being careful. So one thing is you're getting a signed blob, right, from a hopefully trusted entity because it's your peering partner. But nonetheless, you should really go and check not only if in the identity header the signature in itself is valid, but also you're supposed to check if the certificate that you fetch and check whether that is actually valid, whether it has been, issued by a trusted CA, for instance, and it's not just a self-signed one, or whether it's not revoked yet because the carrier was doing, I don't know, some nasty things, and the CA actually revoked the steer shaken certificate for this carrier. And you, as an operator, are supposed, when you get these calls, you're supposed to check these kind of things. Right? And the other thing is, for instance, you're getting a link from, again, hopefully a trusted source. But what if this link is actually just not responding? So you, as a soft switch, are going to try to download this, and it's just going to block, right? So it's not answering for like 60 seconds. And if you're not careful there, then depending on how the soft switch architecture looks like, you're easily blocking all of your core processing threads or processes, right? And calls are not going to be processed. So actually you run into a denial of service here, right? And this is something that you really have to be careful about, do like non-blocking operations in downloading these kind of these kind of certificates, and also ideally cache also negative results. So there are a lot of things to go wrong here. And the other thing is you're supposed to download that via the internet, right? So you might be or you might have the impression that it's always going to be a URL, and whatever comes there you just take it and pass it into curl, right? But as we have seen in these OpenSIP interop tests, what if somebody is sending you a URL pointing to def random, right? And how would that end? And the spoiler is it wouldn't end at all, right? It's going to lock up your process, and your process is going to read from the file. And
you can willingly. You're right. You can willingly do that. That's I never thought of that. Yeah, it's super easy to even if you're async, you're locking up a thread forever.
Yeah, right. Because if you look back how it looks like, right? So here it's basically a URL, right? So and this URL is going to pass into your client web library to fetch the certificate. And if you're not validating the scheme, at least to check if it's HTTP or HTTPS, and whether it's going to point to a proper FQDN and not, I don't know, to localhost, right? You can even start in the worst case exfiltrating local data. If you
to be honest, if you wanted to, you could use a real web server, but have it serve a few gigabytes of video. It will cost you the bandwidth,
right?
But it will still lock up your thread for a long time. So
right.
if you're really willing to do some damage, you can certainly do you certainly do a lot.
Yeah. And there basically is the responsibility of the soft switch vendors to really tighten the security down on this one and make sure that these kind of scenarios are being handled gracefully, right? And this is one of the things my steer shaken test suite is addressing, that you really check if the system on the test can handle these kind of scenarios for you. Talking about the test suite, what I've done is I've taken SIPP and added certain patches to it in order to be able to create valid and also invalid identity headers. And if you get a call in with an identity header, to be able to validate what you got. Right? So what I did is adding a new identity keyword that you can put into your scenario files. And if it's there, SIPP is going to craft a proper identity header, valid or invalid, depending on your scenario, and it's going to send it out. And if you're going to get back, or if you're going to receive an invite, you can put a new action there with an execution saying validate with a certain key or with a certain certificate the identity header and report whether it's valid or not. And along with that, there are also helpers to inject invalid identities, because the good thing is from an ecosystem point of view, I'm using lib steer shaking from SignalWire for this, and it's actually pretty strict in terms of what you can pass in as parameters, right? So you can very conveniently create identity headers, but since the test suite is supposed to also create invalid headers, the library wouldn't allow me to do this. Yeah, so it's going to already reject certain too long values or wrong timestamps or whatever. So there are helpers that try to inject.
So these were added to SIPP proper, like they're patches to the actual tool?
Yeah, exactly. So what's there basically is there are two repositories, and one of the repositories is the steer shaken scenarios repository, which is basically a collection of shell scripts and the helpers and the scenarios in order to drive the tests. Right, so it's basically a collection of like 50 different test scenarios that you can run, and it's relying on SIPP. Yeah, it comes with a precompiled SIPP version for your convenience, and the SIPP itself has certain patches in there in order to allow these modifications. It's not upstream yet, so there is a fork in the Sipfront GitHub.
Yeah, I guess it's going to be added soon. It's it looks interesting. So it's I hope they add it soon. It's going to be necessary anyways. Like Kamailio has it now. By the way, SignalWire sponsored the development of lib steer shaken, which is in Kamailio now.
Exactly. Yeah.
So there's but this is not using any library, right? It's just basic.
It uses for this particular identity header, for instance, it uses the SignalWire lib steer shaken library.
Oh, it's lib steer shaken. Great. So
exactly.
our team will be happy to hear that. Great.
Exactly. And as I said, I mean, it not for each of the scenarios, because some scenarios require you to inject a completely broken identity header, right? And you just cannot generate that with the libsteer-shaken library, because as I said, the libsteer-shaken library is validating your input, and it's just not allowing you to do all these nasty things. So some scenarios use kind of like a manual creation of the identity header. And the other thing is that comes with steer-shaken, which also is forgotten very often. Steer-shaken not only requires you to provide the identity header, but it also comes with the requirement of putting a date header there. Yeah? And the date header is supposed to be, within 60 seconds. The RFC says,
Yep.
It's up to local policy when you receive a call, like how much outdated the date, the timestamp there is or can be. So it's a bit of a, mutual discussion between carriers of what to allow, or it's just local policy of a carrier what to allow. But I'm expecting this to be forgotten a lot. We've discussed this in the OpenSIP as well. Some carriers did already back in April have steer-shaken support in there, but I think none of them used the date header. Yeah? So the test tool, the test scenario is supposed to also check this existence of the date.
Oh yeah, that's important. Cool. So can people just go and use it right now?
Right. It's the URL is there. Yeah. So it's Sipfront in GitHub Sipfront/steer-shaken scenarios. You can just clone it locally. You have to. It has a quite extensive README. So you need to. This particular repository requires a bit of manual preparation, but it provides you with all the tools to locally generate certificates in order to test things, right? And it provides you with the scripts to run the tests. It provides you with the scenarios and everything.
So I think I'm actually going to do and try this like today because it's
very good,
super interesting.
Let me know how it goes. It's not fully complete yet, so there is still things to check, like whether we test the correct response codes, because that's also something we've seen in the interop tests, that operators and vendors come up with all kind of different codes. It's a bit fluffy, like the definition is not very clear on when to use which kind of response code, so it's a bit hard to test it. So you might need to manually change some scenarios to your requirements. But all in all, the foundation is there, and it helps you launch this kind of tests very easily. Right, and in the end, since you're still required to do a lot of local preparation, so the actual goal, it's not there yet, but what I'm working towards is providing the steer-shaken test scenario as a test bundle in Sipfront. So when you are logging into the Sipfront portal, then you can just say, I want to test all of the steer-shaken scenarios, and just give it like the URL, a list of users that you want to test, and then run it manually. And basically, just to give you also a glimpse on how it looks like, is if you're kind of familiar with SIPP and the SIPP CLI, you might recognize like these core scenarios, like the letter diagram, where you see you're sending certain invites, you're getting or expecting certain responses back, right? You're based on that react with more SIP messages like an ACK. And same thing on a call party, you're expecting to receive an invite, you're then sending out 180, for instance. You're simulating like a pickup delay of like 3 seconds, for instance, and then you're sending a 200 to indicate that you picked up the call. And what basically Sipfront does is it takes the metrics that SIPP is providing in real time, collects all of that, and is drawing that on a web interface in real time. So it's actually a pretty neat GUI for SIPP. So that's what it in a nutshell really is. Right? And on top of that, it also provides you with a very nicely abstracted API So you don't have to remember, these 150 command line options of SIPP in order to run a test, rather than just saying, you have a curl command and you tell it how much cores, and that's about it. Yeah, that basically concludes my stir shaking.
There's so much. Yeah, stir shaking is going to be important. And thank you for that SIP work, by the way, because that is really super interesting, and that's certainly something we're going to work with in the future. I'm really thinking about at least a few things it can do right away. SignalWire is working on call signing, etc., because it's industry standard at this point. So I'm just gonna download and clone the repo like right now and try and let you know. But I'm sure it's going to be very, very fun and very useful.
Right.
Well, thank you, Andreas. We went through a lot. Went through SIP testing, we went through stir shaking, we went through how to test stir shaking, and the various gotchas of testing and the kind of stuff. And well, Andreas Granig, founder and CEO at Sipfront, was with us today. Thank you very much for joining us, Andreas.
It was a pleasure.
And well, I'll see you next week. Thank you very much.